What's up, everybody? This is Tech G back with another video. And in this video, I'm going to be explaining to you exactly what the EIGRP routing protocol is. So let's get into it. When most people hear the words routing protocol, their eyes tend to glaze over. But if you're in the IT game, especially on the networking side, then understanding these protocols is absolutely critical. And one of the big names that you're going to run into is called EIGRP. Now, if you've ever worked with Cisco gear or if you plan to, the EIGRP is going to come up a lot. It's proprietary, it's powerful, and it's packed with features to help networks run efficiently. So, exactly what is EIGRP? How does it work and why should you care? Well, we're going to talk about it in this video. So let's go. All right, so like I stated earlier, EIGRP, this stands for Enhanced Interior Gateway Routing Protocol. It was developed by Cisco as an improvement over its older protocol, which is called EIGRP, or Interior Gateway Routing Protocol. Now, while EIGRP had some strengths, it was not designed to scale well as networks became larger and more complex. So Cisco decided to go back to the drawing board and build something better, or something that could handle the demands of modern networks. And EIGRP, this is classified as an advanced distant vector routing protocol, though many refer to it as a hybrid protocol because it blends features of both distance vector and link state protocols. And essentially, this gives it a unique sweet spot in terms of speed, scalability, and efficiency. And also, it was Cisco proprietary for many years, which meant you could only use it on Cisco devices. But in 2013, Cisco released EIGRP to the IETF as an open standard, or at least partially, which made it more accessible. All right, so the question is, why do we use EIGRP? Well, here's the deal. EIGRP offers faster convergence, which allows it to react quickly to network changes. It also makes more efficient routing decisions by using metrics based on bandwidth, delay, reliability, and load. It also has support for unequal cost load balancing. So most protocols, they support equal cost load balancing, but EIGRP lets you use multiple paths for different metrics. It also supports scalability because it works well in both small and large enterprise networks, and it's flexible to where it can support multiple network protocols like IP version 4, IP version 6, IPX, and AppleTalk. Although most people only care about IP version 4 and IP version 6. So if you're working in a Cisco-heavy environment, then EIGRP is often a go-to protocol for dynamic routing. All right, so let's talk about EIGRP metrics. So the EIGRP protocol doesn't just look at hop count like the RIP protocol does. It uses a composite metric, which means it takes multiple factors into account to choose the best path. And these factors include the following, such as bandwidth, which is the slowest link along the route. There's delay, and this is the cumulative delay across all links in the path. There's reliability. This is the value between numbers 0 and 255, with 255 being 100% reliable. There's load, and this is basically how busy a link is, and it's also scaled from 0 to 255. And then there's MTU, or the maximum transmission unit, and this is used in tie breaking, and it's not necessarily a metric itself. But by default, EIGRP typically uses just bandwidth and delay in its metric calculation, but the other metrics are available if needed. All right, so let's go ahead and talk about some of the terms and mechanisms that make up EIGRP. So the first key concept is called dual, and that stands for diffusion update algorithm. And this is at the heart of EIGRP. It basically ensures loop-free and backup routes without depending on slow convergence. So here's what dual actually does. It determines the best path to route to a destination, and this is called the successor. It then identifies backup routes, which are called feasible successors that can be used immediately if the main route fails. And then it maintains loop-free routing by checking the feasibility condition. And once again, when it comes to successor and feasibility successor, remember that successor, this is basically the best primary route for data to travel. And then you have a feasibility successor. This is a backup route that's loop-free but meets the feasibility condition. So if a route's reported distance from a neighbor is less than the local feasibility distance, then it qualifies as a feasible successor. And this allows for instant failover where no recalculations are needed. And then there's this concept called neighbor relationships. So EIGRP routers, they form neighbor relationships by sending hello packets. And once neighbors are established, they can exchange routing communication. And then you have what is called a default hello interval. And they can be 5 seconds or 60 seconds. If they're 5 seconds, they'll be on high-speed links like Ethernet. If they're 60 seconds, they're going to be on low-speed links like a T1. Now, if a router doesn't hear from a neighbor within what is called the hold time, which is usually 3 times the hello interval, then it assumes that the neighbor is down and recalculates a route. And then another key concept is called the topology table. So each EIGRP router maintains a topology table, and this is basically a record of all learned routes, even ones that are not currently being used. And it includes all available paths, it includes all the metrics such as bandwidth and delay, and it includes the successors and feasible successors. But only the best routes will make it into the routing table. All right, next we have what are called EIGRP message types. So EIGRP uses several message types to communicate between routers. First message is called hello, and this is used to discover and maintain neighbor relationships. You have the update message. This is used to send routing information. You have the acknowledgement message. This confirms reliable receipt of an update. You have the query message. This is sent when a route is lost and no feasible successor exists. And then you have the reply message, and this is sent in response to a query containing route information. Now, what's cool is that EIGRP is selective about how it communicates. Unlike the RIP protocol, which floods updates periodically, EIGRP only sends updates when something happens, and that reduces bandwidth usage and improves efficiency. All right, next we have what are called EIGRP timers. So you don't have to tweak timers very often, but it's good to know how they work. And the first type of timer is called a hello timer. And this is basically how often EIGRP sends hello packets. You have a hold timer. This is how long a router waits before declaring a neighbor is down. And then you have what is called the retransmission timeout. And this is how long a router waits before resending a packet if no acknowledgement is received. And you can fine tune these settings for performance, especially on wide area network links. All right, next we have what are called autonomous systems in EIGRP. So EIGRP is organized around autonomous systems, and when you configure EIGRP on a router, you assign it an autonomous number, such as 100, as you can see on your screen written in red right there. And all routers within the same autonomous system will basically exchange routing information with each other. And this is similar to how the border gate protocol uses autonomous numbers, but on a smaller internal scale. Next, we have EIGRP for IP version 6, and the configuration is a bit different. So instead of using a global router process like you do in IP version 4, you would just configure EIGRP for IP version 6 on each interface, and you can see the commands written there in red on your screen. Now, some other differences include the following when it comes to EIGRP on IP version 6. So basically, there are no network statements because you have to enable it per interface. You're going to use linked local addresses for neighbor discovery, and it requires a router ID that is manually assigned. Now, IP version 6 support makes EIGRP a forward-looking protocol, even though many enterprises are still slow to adopt to IP version 6. All right, next let's talk about EIGRP route types real quick. So not all EIGRP routes are created equal. So there are 3 main types. The first type is called an internal route, and this is learned from other routers within the same autonomous system. You have what are called external routes, and these are routes that are redistributed into EIGRP from another protocol like OSPF, RIP, or BGP. And then you have what is called summary routes, and these are manually automatically summarized routes. Also, external routes tend to include a lot of extra information in the routing table, such as an origin protocol and administrative distance. And speaking of administrative distance, so EIGRP has an administrative distance of 90 for internal routes and 170 for external routes. And that makes internal EIGRP routes more preferred than OSPF, which has an administrative distance of 110, but external EIGRP routes are less preferred. Now, why does this matter? Well, because when multiple protocols are in play, routers use the route with the lowest AD or administrative distance. All right, so let's move on and talk about load balancing real quick. So one of EIGRP's coolest tricks is its support for unequal cost load balancing. So most protocols only load balance across paths with the same costs, but EIGRP uses a command called variance to include less than perfect paths in the mix as long as they meet certain criteria. And on your screen right here at the bottom, this is an example of how to set that up. And basically, this tells EIGRP to include paths with a metric up to twice as long as the best path, allowing for smarter traffic distribution. And on your screen right here, here's an EIGRP configuration for IP version 4. So let's say that you have 3 routers and you want to enable EIGRP. So here's your commands. You would type router EIGRP 100. You would type network, then 192.168.1.0, then network.192.168.2.0. And that's pretty much it. And after you do all of that, EIGRP is going to start sending hello packets on those interfaces. It's going to discover neighbors. It's going to exchange routes, and then it's going to populate the topology and the routing tables. And then you can add the no auto summary command if you're dealing with discontinuous subnets, especially in modern CIDR-based networks. All right, so let's recap with what makes EIGRP a solid choice. Well, when it comes to EIGRP, it has rapid convergence thanks to dual. It has efficient use of bandwidth because it has no periodic updates. It has loop-free routing. It has multiple path support, including unequal costs. It's scalable and flexible, and it supports IP version 4 and IP version 6. So essentially, it's fast, it's smart, and it's easier to configure than OSPF in many cases. Now, when it comes to the disadvantages, well, one of them is it is proprietary. So while it is partially open, full compatibility across vendors is still limited. It's also less widely supported outside of Cisco ecosystems. It can be complex because the metric calculation and dual algorithm can be harder to grasp compared to simpler protocols. And it's not the default in many environments. OSPF is still more widely adopted in multi-vendor setups. So basically, it's perfect if you're in a Cisco world, but it might not be the best fit in a mixed environment. All right, so let's go ahead and wrap this up. So if you're working in a Cisco only network, which is still very common in enterprises, the EIGRP is a fantastic choice. It offers fast convergence, stable performance, and tons of features that simplify network management. Now, if you're studying for Cisco certifications like CCNA, CCNP, or beyond, then you definitely want to get familiar with EIGRP because it's going to show up in labs, exams, and real-world scenarios. But if you're in a mixed vendor network, then OSPF might be the safer bet since it's an open standard and universally supported. But either way, understanding EIGRP gives you a deeper appreciation for how dynamic routing works behind the scenes. Now, it's not magic. It's just math, logic, and a little Cisco engineering finesse. So whether you're configuring all this stuff in a home lab or you're just learning this stuff to prepare for a networking job, the EIGRP is definitely worth knowing.